In this video, we're going to be testing a mean with a known sigma. So our problem reads, according to the Bureau of Crime Statistics and Research of Australia, as reported on LawLink, the mean length of imprisonment for motor vehicle theft offenders in Australia is 16.7 months. 100 randomly selected motor vehicle theft offenders in Sydney, Australia had a mean length of imprisonment of 17.8 months. At the 5% significance level, does the data provide sufficient evidence to conclude that the mean length of imprisonment for motor vehicle theft offenders in Sydney differs from the national mean in Australia? Assume that the population standard deviation of the lengths of imprisonment for motor vehicle theft offenders is 6 months. So the first thing that I'm going to do is locate all the information I'm going to need. So we have 16.7 months. That's our mu. And then we have a mean length in Sydney of 17.8, and that's our x bar. We have 100 randomly chosen people. That is our n, 100. We're using 5% significance level. And the standard deviation, the known standard deviation, is 6 months, so we know sigma. So we're going to use a z-test. And now it wants to know if the length of imprisonment for motor vehicle theft offenders in Sydney differs. So differs is the key word. That's going to tell us that we're using a two-tailed test. So now the first thing that we want to do is set up our null hypothesis and alternative hypothesis. So we have H0 and H1. And since the word differs, we just want to know if it's different. So we have a two-tailed test. So we're going to say mu is not equal to 16.7, which is our mu. And then our null hypothesis is going to be mu is equal to 16.7. And now we want to find our critical value. And because we know sigma, we're using z. So z crit is equal to. So now we're going to go to our t-table. And we have a two-tailed test with a 5% significant. So we have two tails cross to 0.05 and now down to z. So I have 1.960. So we have this critical value. And because we're two-tailed, we're going to need to use plus and minus 1.96. So that means we're going to reject H0 if zcalc is less than negative 1.96 or if zcalc is greater than 1.96. So now that we've set up our rejection regions, we're going to find our zcalc. So zcalc is equal to x bar minus mu divided by sigma divided by the square root of n, and that is equal to x bar in our problem was 17.8 minus mu, which is 16.7, divided by sigma, which was 6, divided by the square root of n, and n was equal to 100. And when we put this into our calculator, we get 1.83. And we can see that 1.83 is not greater than 1.96, so we're going to fail to reject H0. And now we need to write a statement telling us what it means when we're failing to reject. So we're failing to reject our H0, which means we're saying that mu is equal to 16.7. At the 5% significance level, our data does not provide sufficient evidence to conclude that the mean length of imprisonment of motor vehicle theft offenders in Sydney differs from the national mean in Australia. And now the last thing that we're going to do is find our p-value. So we're going to go to our z-table and we're going to look up 1.83. Okay, so we go down the z to 1.8 and then over to 3. So we find 0.9664. And it's important to remember that the table always reads left. So since we're looking at greater than, we're going to have to do 1 minus. So when we do our p-value, we're going to have 1 minus 0.9664. And then we also have to remember that this is a two-tailed test. So we have to multiply that by 2. So our p-value is equal to 0.0674. And since our p-value is greater than our significance level, which was 0.05, it confirms that our data does not show significant evidence that the mean imprisonment time is different. And that's our video on testing a mean with known sigma.